Unit 8, Probability and Measurement, Lesson 1, Representing Sample Spaces. Your objectives for this lesson are to use lists, tables, and tree diagrams to represent sample spaces, as well as to use the fundamental counting principle to count outcomes. Okay, so let's start off by defining sample space. Sample space is the set of all possible outcomes. So when you describe the outcomes, you've described the sample space. And you can do this by using an organized list, table, or tree diagram. There are probably other ways that you could do this also, but these are the only 3 methods we're going to look at in this class. Okay. Example 1. Maurice packs suits, shirts, and ties that can be mixed and matched. Using the packing list, draw a tree diagram and an organized list to represent the sample space for business suit combinations. So you can see Maurice's packing list. He has gray, black, and khaki suits, white and light blue shirts, and he has one tie which is striped, but it's optional. So what I'm going to do first is abbreviate each of these terms so that I'm not writing out gray, black, khaki 100 times. So gray will be G, black B, and khaki K. For shirts, I'm going to use white, so W, and light blue, I'm going to use L. You could write LB if you want to. And then tie or no tie, so tie and no tie. Okay. So my tree, we're going to start off with one root here. So my root is outcomes. You could call it outfits if you wanted to, because these are outfits, but I'm going to call it outcomes. And my first branch off is for what color is Maurice's suit. So suit. And we said gray, black, khaki. Okay. Then from here, he has some choices to make about the shirt. So each of these, he has 2 options as far as which shirt he will wear. So I'm going to draw 2 branches off of each suit. So this is shirts, and he could wear white or light blue. And so what this is showing is he could wear a gray suit with a white shirt, gray suit, light blue shirt, black suit, white shirt, black suit, light blue shirt. Then the last branch here is going to be for ties. Do this one in green. So ties, either tie or no tie. Tie, no tie. Tie, no tie. Okay. This is a little tedious, but it does show, at least I think it shows the path of the decision making the best. Okay, so the T's and N's. Now the last thing I'm going to do is I'm going to actually draw a line from each of these to show his final step here, the final combination. Okay, we'll do these in red. So we're just going to go along here and trace. So he could wear gray with white and a tie. That would be G, W, T. Gray with white, no tie. Gray, light blue, tie. Gray, light blue, no tie. Okay. Black, white, tie. Black, white, no tie. Yes, so as you can see, Maurice has many outfits to choose from. And you could count these up. There's actually 12 outfits, but this is our sample space right there. These are all the different combinations. And you might be saying to yourself, well, I kind of hate that tree. That looks too hard to do. And well, you could do an organized list instead. The organized list is essentially this right here. So if you wanted to do the organized list instead of the tree, you would use the initials like I did before, and you're just going to write those combinations with commas in between them. So that would be like GWT, comma, GWN, comma, GLT, comma, GLN, comma, and just write them all down. Don't leave anyone out. And this is a little bit less work. Some people think it's less organized and harder to understand, but it's less work and less writing for you. Okay. Example 2. Michelle could take a summer job in California or Arizona at a hotel or a bed and breakfast. And we're going to represent this sample space by making a table. So just like before, I'm going to label this outcomes and make kind of a tic-tac-toe board here. Okay. So it says she could go to California or Arizona. So this is if she goes to California, you could write CA, or Arizona. And she could work at a hotel, or she could work at a bed and breakfast. And you might be asking yourself, well, why does California and Arizona go over here? Why don't they go on top? It could have gone on top. You could put either one together, but make sure you keep the places together and keep the jobs together. And basically what we're doing now, this box, you can see, is where hotel and California kind of meet. They get together. So I'm going to write C for California, then H for hotel. The box beneath it is where hotel and Arizona meet. So my answer would be A, H. So this one is C, B for bed and breakfast, and A, B, bed and breakfast. And then this is my sample space. Okay. The fundamental counting principle says that the number of all possible outcomes for an experiment can be found by multiplying the number of possible outcomes from each stage or event. So for instance, in that first example, maybe Maurice didn't have just 12 possible outcomes because maybe he'd had, instead of 3 suits, maybe he has like 6 suits, and instead of 2 shirts, he has 7 shirts, and then he has 15 ties to choose from, and he wants to know, how many outfits can I get? Well, you could sit there and make a tree diagram all day, but I wouldn't personally want to do that. So that's where the fundamental counting principle comes in. It makes things a lot easier. So let's take a look at this one. Example 3. The pattern for a certain license plate is 3 letters followed by 3 numbers. The letter O is not used as any of the letters, and the number 0 is not used as any of the numbers. Any other letter or number can be used multiple times. How many license plates can be created with this pattern? So the first thing I'm going to do, I'm going to put 6 blanks here to represent the 6 characters on my license plate. Okay. And I know that there are 26 letters in the alphabet. Of course, we're going to say minus 1 because we're not using O, because O and 0, that would be confusing on a license plate. And we get 25. So on my first character here, it's a letter. I have 25 possibilities. So this is the number of possibilities. The second character, also a letter, I'll have 25 again because I could have the same letter all 3 times. So of course this is also 25. Now numbers, single digit numbers, because each space is going to be one character, one digit. We have just 1 through 9. And if you counted these up, you do have 9. So we have 9 possibilities for each of these. Now that you have your number of possibilities, all you need to do is multiply. And this is a very large number. You should get 1,139,0,625. So 11,390,625 license plates can be created. It's a pretty good amount with just 6 characters. Okay, and that concludes lesson 1.